is shaking because of the fan. Fan create we do it every day. Okay, good evening, children. I can see some of you have joined in. I don't know what we start with a fancy name, Fatal Union, and then we have Aarti Pawan Pandey, we have Khushi Verma. Good evening, children. Welcome. In the previous session of Wisdom 360, we had studied about the center of gravity, right? We had also studied center of gravity of regular bodies, and we also had studied how to find the center of gravity of a body which is not regular in shape. Now today we go to the last part of this chapter, and the topic is uniform circular motion. Some more people are joining in. Okay, so we continue. The scope of the syllabus in this is very simple. The syllabus says that the child should know that a body can always, a body can move in with constant speed in spite of a force being acting on it, that is centripetal force. And the second, they have asked us just to tell the difference between centripetal and centrifugal. Very simple, very small topic. Today we'll be touching upon this topic. Okay, Aarti Pawan. So, okay, it's Vaishnavi. So Vaishnavi, just if you could, while entering, you could write your correct name. It becomes easier for me. Join with your own ID. It becomes easy. Okay. I'll try to remember though. Okay. So we start now. So what is circular motion? What is motion first of all? Anybody can tell me? Okay. It takes some time to type. Okay, I'll tell you. See, if a body is changing position with the passage of time, then we say that the body is in motion. For us to know that the body is actually changing position. Yes, yes. Aarti Pavan Pandey, good evening, beta. Nikhil has joined in. Okay, so how do we know that the body is changing position? For that, we need to have a reference point. Okay, so now I have a reference point, and in relation with the reference point, if the body is changing its position with the passage of time, we say that the body is in motion. Okay, so now what is circular motion? What is circular motion? See, again, we have studied motion. Obviously, it has to be in a circular direction. Okay, I mean, it has to be in a circular path. If the motion is in a circular path, it is known as circular motion. So now I take this as a reference point. Okay, and the body is changing positions. It was over here sometime before, after some time comes here, after sometimes come here. Okay, what is common in all these? That this distance is the same. This distance is the same. We know that. What is this called? This is called the radius of the circle, which means this body is in motion in a circular path. With the passage of time, its position is changing, but it is always at a fixed distance from a point. So this is circular motion. Okay, now that we have done circular motion, I keep on rubbing, I've written the reference point so that I know I've touched on this. So now we have understood what is circular motion. Next we go Shamam Faridi. Good evening, Shamam Faridi. The uniform and non-uniform. It's very simple. Okay, if the body is covering equal distance in equal intervals of time, it is uniform. And if the distance covered is not equal, then it is non-uniform. Okay, which means if the speed at all these three positions is same, then it is what? Good evening. Tell me. If the speed at all these three instances is same, then what kind of circular motion are we talking about? Quick. Punch in your pads. Let me see your answers. Should I repeat it? Uniform. Very nice. Uniform circular motion. Just like that, Tarun. Okay. Just like that, Tarun says that it is uniform circular motion. And if the speed here was 10 meter per second, here it becomes 15, here it becomes 17, then it is non-uniform, which means now it is covering. Very nice, very nice. Audio not clear? Okay, let me set up the audio a little. Let me set up the audio a little. Bring it closer to me. Okay, is it better now? Is it better now? Piyush? Who said audio is not better? Audio is not good. So, fatal union. Yes, fatal union. Is the audio good now? Yeah, clear. Very nice. If your signals are slow, sometimes, that buffering takes place, and so the picture quality and the sound goes. What you can do is once the lecture is over, you can go back again and watch it all over again. Then you will see, or we post it on our website the next day. Of course, you should go there, comment there. I love your comments. Keep on looking for comments here also. So you can always watch it once the lecture is over, once the live lecture is over. We post it on our site, Wisdom 360. Okay, we have done a wonderful job. Within 15 days, we have posted 200 videos. Okay, so you can always go there, watch the videos. We come back. Okay, so we go to speed during uniform circular motion. Okay, now if it is uniform circular motion, I told you at any instance I take the speed, it will always be the same. Okay, it will always be the same, which means if I take the four quarters, okay, one is over here, the other is over here, the third is over here, and the fourth is over here. Okay, if I take the speeds at these four positions A, B, C, and D. Okay, and if it is uniform circular motion, then what will be the speed at these 4 points? Quickly, punch in. What will be the speed at these 4 points? Will it be same? Will it be different? Punch quickly. Will it be same? It will be, Piyush says it will be uniform. By uniform you mean it will be the same, right Piyush? So Piyush is the one who gets it right. So it will be the same. Now in each quarter, which means that each quarter of the circle has cut down on fancy names, and you're bringing more and more fancy names. Okay? Is covered in the same time interval. So it is uniform circular motion. Now what about velocity? Okay? Velocity here. What will be the direction of velocity at point A? Anybody, quickly. What will be the direction of velocity? I didn't mention what direction. It will be different. Now I say, okay. Now I say that this particle is going round in anti-clockwise direction. Now you can tell me, if this uniform circular motion is in anti-clockwise direction, now tell me what will be the position at A of velocity. Very nice. Piyush Kumar Gupta says tangent. Okay, so I draw a tangent over here. Okay, and the tangent will give me the direction of the velocity, and my tangent at A is pointing towards the north. Okay, so my velocity is towards the north, right? What will be my velocity at B? Again, I draw a tangent here, and this time it is pointing towards the west. So my velocity's direction is towards the west. Now if I look at position C, then the direction of my velocity as per the tangent drawn is towards the south. And finally at position D, again I draw a tangent, and now the direction of velocity is towards east. All of you know that velocity is a vector quantity, got it? It has to have direction. When we were talking about speed, we were not talking about direction because speed is a scalar quantity. But as soon as we came into velocity, we started, yeah, Aarti Pawan Pandey says west, very nice. Okay, so all of you now know that we are looking at only 4 points. If I look at points between, small points between them, all of them will have different directions, which means velocity is changing. Got it? At any instant, the particle is having different velocity. Okay? Is the speed changing? Is the speed changing? Yes, no. Quickly. Is the speed changing? No answers. I want a yes or a no. No. The speed is not changing. It is uniform circular motion. Piyush Kumar Gupta, Aarti Pawan Pandey, Suyash Vaibhav, all of them are right. The speed is not changing. Just like that also says, just like that, so it's not changing, okay? So the speed is not changing, but the velocity is changing. Why is the velocity changing? Because the direction of velocity is changing. Okay, so at any instant, we have covered this also, the velocity at any instant changes, and it is changing, okay, because some force is acting. Before going into that, they have also asked you to know the difference between uniform circular and uniform linear motion. Okay, so now let us take examples of uniform linear motion. We studied in the previous class. Okay, I say the body was at position A and it covered equal distances in equal intervals of time, okay, and came to D. There also we said that it is covering quarters in the same time interval. That's why it's uniform circular. So here also it is doing the same thing, okay, from A to B, from B to C, from C to D, and okay, it is taking the same time. Okay, so what kind of motion is this? Shoot quickly, what kind of motion is this? It is covering equal distances in equal interval of time. This is linear motion, okay? Here we are talking about linear motion. Say it is uniform linear motion. So this is uniform linear motion. Okay, the next question which I ask is it accelerated? Is this accelerated motion? Is this accelerated motion? Yes. Vaishnavi says yes. No. Piyush and Anushka Sahai say no. And no, it is not accelerated. Okay. It continues with the same velocity. The velocity is not changing. So it is velocity also is same. So if the velocity is not changing, this is not accelerated motion. Got it? Which means the body is non-accelerated. Okay. On the other hand, here also the speed remains the same, but the acceleration is 0. Whereas when I go to uniform circular motion, the speed remains the same, okay, which means it is covered distance in the same time interval, but it is accelerated. How is it possible? How come this has become accelerated? Can anybody write a line to me? How has this become accelerated? What difference did I tell you between both two? What is changing? One word. What is changing? What is changing between the two? What is changing between the uniform linear motion and uniform circular motion? Velocity is changing just like that. Okay, brain teaser also says velocity is changing. Okay, So velocity is changing between the two. Got it? Now the speed is not changing. How is the velocity changing? The velocity is changing because the direction is changing. We have very nice. Suyash Vaibhav says because the direction is changing. Okay. So we have already discussed that in uniform circular motion, the velocity keeps on changing because the velocity keeps on changing. Okay, and hence it is accelerated motion, right? So we have understood the difference between velocity was not changing. Why was it not changing? Because the body was continuously going in one direction only. The body was continuously going in one direction. It was covering it was having displacement in equal intervals of time. Okay, so there is no change in velocity. Change in velocity, there is no acceleration. Okay, the rate of change of velocity is acceleration, so the velocity is not changing. But here, although the speed is same, the velocity is changing. Why is the velocity changing? Because why is the velocity changing now? Come on, why is the velocity changing? Why is the velocity changing? One, two words you need, just two words. Okay, the direction is changing. Why is the direction changing? See, now if I'll go forward, okay, the velocity is changing because the direction is changing. Vaishnavi says she is right. Piyush also says because the direction is changing. Shuyas also says the direction is changing, and all of you are right. Okay, but if the direction is changing, if the velocity is changing, which means it is accelerated motion. Okay, and we know that F, which is a vector quantity, is equal to mass into acceleration. Okay, which again is a vector quantity. So if there is acceleration, there has to be force, right? अगर बॉडी एक्सेलरेटेड मोशन दिखा रही है तो उसके ऊपर कोई फोर्स जरूर लग रहा है. Without a force, a body can never be accelerated. Okay, I need a force, only then the body gets accelerated. To stop a body also I need a force, only then it stops, slowly it retards. Got it? So if it is accelerated, it has to have a force. Now where is the force acting? Okay, now before going to that, I tell you a bit of geometry. Okay, in circles, you may study, I don't know, you have studied or you may study, it's there in your syllabus. Okay, that a tangent touches a circle at a point, that point is known as point of contact. If I draw a radius to this point of contact, okay, if I draw a radius to this point of contact, then the angle formed between this radius and the tangent is 90 degrees. Got it? Everybody understood? Everybody understood that much? Okay. So we'll be using this now. You have understood that if there is acceleration, then there has to be a force present. Okay. So now a body is going in a circular path. Okay. The particle is over here. Okay. At this point, what is its direction of velocity is this. Okay, now I see that at another instance the direction has changed. Now it is this. Okay, how is it possible? It is possible only if I have a force acting in this direction. Got it? Again at this instant, a very next instant it is over here. So again I have a force acting. Okay, again I have a force acting on this body. Okay, so everywhere this keeps on turning because a force is constantly pushing it in. Okay, that's why otherwise it would have gone in the direction of tangent. Okay, which means if I bring it in, okay, I see all these forces, I see that all these forces, they are acting towards the center. Okay, all these forces are acting towards the center and all of them are acting along the radius. Since it's perpendicular, I can bring it in. Okay, so all of them are acting towards the center and all of them are acting along the radius. Okay, so what is this force called? This force is called centripetal force. Everybody understood? Give me a yes, or I explain it to you once again. Let me see how many yeses do I get. Everybody understood? Waiting for your response. You want me to explain it again? Okay, here we go again. See, now when the body is moving in uniform circular motion, we say that its velocity's direction can be found by drawing a tangent. Got it? Velocity's direction can be found by drawing a tangent. At any instant, when I draw a tangent to the path, that gives me the direction of velocity at that instant. Okay, so I can see that every instant the velocity's direction is changing. Got it? Now, second thing, I say that if velocity is changing, it means that this is accelerated motion. Okay, then the third thing which I say that if it is accelerated, then we know that F is equal to m into a, which means if it is accelerated, I'm sure it has to have a force acting. What is this force doing? This force is helping change the direction of, change the direction of the velocity. Got it? So, how should this force be acting? We all know that it should be acting perpendicular to it. So, if it is acting perpendicular to it, we already know that at the point of contact, the radius and the tangent to a circle are at 90 degree to each other. Okay, which means if I extend it, then all of them are acting perpendicular. Got it? All these forces are acting perpendicular. And where are they heading? All of them are heading towards the center. Got it? And where are they acting? All of them are acting along the radius. So a centripetal force is always directed towards the center and it acts along the radius. Everybody understood? It's a real force. Okay, we'll study centrifugal in the next lecture. So then we'll compare. That's why I'm telling you once again, it's a real force. It is not changing, but the velocity is changing. Why is the velocity changing? Because something is pulling it. So centripetal means center seeking, which wants to go towards the center. So I told you all the forces the center along the radius. Centripetal is center seeking. All the forces want to go towards the center, and at those instances they keep on changing the direction of the particle and it becomes accelerated. Everybody understood? It's very simple. Give me a yes quick. We got 7-8 more minutes. I'll have to do 3 those examples and this topic gets finished. In the next class we will do centrifugal. Got it? Give me a yes quickly. I already got some just like that says yes sir. Brain teaser says yes sir. Vaibhav Singh says yes sir. So we move forward. Let me have a look. It's a very simple topic. I hope all of you must have understood, isn't it? And now the last part of it wherein they give some examples. The first example we take an atom. Okay. I'll erase all this now. And atom have the protons and the neutrons in the middle, and then I have electrons going around in circular orbits. Yes, all of you know that. Okay, so they keep on going in, they are in uniform circular motion. Okay, so is the centripetal force acting on it? If yes, what is this centripetal force? What do we have a centripetal force acting on the electrons? If yes, what is that centripetal force? Punch, come on, quickly punch. Not that What is that centripetal force? Quickly, you don't have much time. 6-7 minutes left. Punch in quickly. Waiting. No? I don't get any messages. Do we get any messages? No, I didn't see any. So we're not getting. So I'll tell you. Yes, we have a centripetal force acting, and this, okay, there it comes. Now, just like that, says electrostatic force, and you are absolutely right, just like that. Okay, electrostatic force. We know that we have the protons here, okay, which are positively charged. Okay, and the electrons we know are negatively charged. Okay, so there is an electrostatic pull. Okay, these protons, they have, we know that opposite charges attract each other, so these protons pull the electrons towards themselves. So these electrons constantly are experiencing a force which is acting towards the center along the radius, and hence they keep on going in circular motion. Of time, let's go fast, because the next one, okay, the next one is a planet. It's a simple, I hope all of you will get it. Okay, we have the sun, you have the earth going around it. Okay, is acting on the earth? Okay, if yes, what is that centripetal force? Be quick, simple questions. This everybody knows. I'm sure we studied it in detail in class 9. If somebody can give me the formula, wonderful. I would love it. Let me see. Punch in quickly. Is there a centripetal force acting? If yes, name it. Very nice. It is the gravitational force, says Vaibhav. Vaibhav, you are right. Sanjay says gravity of the sun. So gravitational force, okay, which is, which is the centripetal force. So the earth is constantly pulled towards the center along the radius, which means it's the centripetal force. So the earth keeps on going around the sun in uniform circular motion. Clear, everybody? Now we are in time. 6 minutes to go, and we are the last. Okay, it's the same one. Now they say that the earth is here and we have the moon over here, the satellite of the earth. Okay, this years, and so the moon continues, the satellite of the earth continues to orbit the earth in uniform circular motion. Okay, now the last example. Which is the last example? Okay, now when a stone, can I have that iCard please? Okay, now the last example, okay? The last example, I have this iCard, okay? I wall it, I'm walling it, okay? I'm ensuring that the speed remains the same, okay? Is there a there it goes, okay? So done. You tell me. So what is this centripetal force? I have, instead of iCard, I'll take a stone which is tied to a string, and it is going around in a uniform circular motion. Okay, it is going around in uniform circular motion. What is the centripetal force here? And yes, the tension on the string is pulling it towards the center along the radius. So this tensional force ensures that it is giving a centripetal force, and because of this centripetal force, it continues to move in a path. You saw that as soon as I left the string here, and it flew like this straight to my kids and hit them in the eye. Got it? So as soon as this centripetal force is stopped, it continues to move in the tangential direction along the tangent in a straight tangential path. Okay, I hope all of you enjoyed the lecture. I hope all of you have understood. Next class when I come, I will do centrifugal force, okay, and the differences between them, and this chapter comes to end. Thank you very much. I hope you